Black box testing is a software testing method that focuses on evaluating the functionality of a system without considering its internal structure or implementation details. This approach treats the system as a black box, focusing solely on the inputs and expected outputs. So, what is black box testing? How is it useful for all of us in our software testing? We will discuss all that in this video. In black box testing, functionality takes center stage. The tester acts as a user, providing inputs and observing the system's behavior and outputs. This user-centric approach validates the system's functionalities against its intended purpose, all without needing to peek under the hood and examine the internal code or structure. Black box testing thrives on a philosophy of no peeking behind the curtain. The tester treats the system as a self-contained unit, focusing solely on its functionality and behavior from a user's perspective. There's no need to decipher lines of code, understand intricate design choices, or unravel the system's architecture. This independence from internal workings allows black box testing to be conducted effectively, even by those without programming expertise. In black box testing, the tester plays the role of a user interacting with the system in real-world scenarios. They meticulously craft inputs, simulating various user actions and data submissions. Once these inputs are fed into the system, the tester becomes an observer, meticulously examining the system's outputs. Do these outputs align with what the user would expect based on the system's documented functionality? By meticulously comparing the provided inputs and the resulting outputs, the tester can identify discrepancies between the intended behavior and the system's actual performance. Now that we've explored black box testing, we can see how it brings several advantages to the table. In black box testing, the tester sheds any preconceived notions about the system's inner workings. This approach ensures an unbiased and objective evaluation, focused solely on the system's functionality from a user's perspective. Without getting tangled up in the intricacies of the code or design, black box testing delivers a clear picture of how well the system performs its intended tasks in real-world scenarios. Black box testing eliminates the need to become an intricate clockwork detective. The tester doesn't have to spend time untangling the system's complex inner workings, like its architecture or intricate code. This streamlined approach translates to a significant reduction in complexity for both planning and executing test cases. With a clear focus on the system's functionality from a user's perspective, black box testing allows testers to design and conduct effective tests with greater efficiency. Black box testing casts a wide net when it comes to scenario coverage. By focusing on the system's functionality from a user's perspective, it can encompass a vast array of user interactions and potential use cases. This comprehensive approach ensures that a broad spectrum of scenarios is evaluated, leaving no stone unturned in the system's functionality. Imagine a tester as an explorer venturing into uncharted territory. Black box testing equips them with a map guided by user experience, allowing them to discover and examine a multitude of pathways and functionalities within the system. Equipped with the knowledge of black box testing's benefits, we can dive deeper and explore the specific techniques testers employ. Equivalence partitioning takes a strategic approach to testing inputs. Imagine the range of possible inputs as a vast territory. Equivalence partitioning divides this territory into manageable sections, each representing a class of similar data. These classes share the same expected behavior from the system. The tester then meticulously selects a representative input from each class. By testing these carefully chosen inputs, the tester gains insight into how the system handles all the other values within that same class, ensuring comprehensive coverage without needing to test every single possibility. When it comes to testing inputs, boundary value analysis zooms in on the edges. Imagine the valid input domain as a well-defined field. Boundary value analysis pays close attention to the borders of this field, focusing on both the valid values allowed and the invalid values that shouldn't be accepted. The tester meticulously selects inputs right at the boundary lines, the highest valid value, the lowest valid value, and values just outside the valid range on either side. By testing these critical points, the tester can identify potential issues with the system's handling of inputs, ensuring it behaves as expected at the fringes of its defined input domain. Decision table testing takes a structured approach to untangling the web of inputs and expected outputs. Imagine a complex decision tree, where various combinations of user inputs can lead to different system responses. Decision table testing captures this relationship in a clear and concise format. The table meticulously lists all possible input conditions, along with their corresponding expected outputs. This organized format allows testers to systematically explore every combination of user actions and verify that the system behaves as intended in each scenario. Imagine stepping into the shoes of a user and navigating the system firsthand. Use case testing takes this user-centric approach to its core. The tester meticulously crafts scenarios that mirror real-world user interactions. These use cases might involve a user logging in, creating an account, performing a specific task, or encountering an error. By simulating these scenarios step by step, the tester observes the system's behavior from the user's perspective. Armed with this arsenal of black box testing techniques, we can now delve into the structured approach testers follow to conduct a thorough evaluation. The foundation of effective black box testing is a deep understanding of the system's purpose. This initial phase involves meticulously analyzing the system's functional requirements, which serve as a blueprint for its intended behavior. Additionally, design specifications, which delve into the system's plan structure and functionalities, are thoroughly reviewed. By immersing themselves in these documents, testers gain a clear picture of what the system is supposed to do. This knowledge becomes the cornerstone for crafting effective test cases that accurately reflect real-world user interactions. Once the groundwork is laid through requirements analysis, the exciting world of test case design unfolds. In this phase, testers transform their understanding of the system's intended behavior into a series of practical tests. These test cases are meticulously crafted, focusing solely on the system's functionalities from a user's perspective. The internal workings of the system remain a mystery. The testers are unconcerned about the intricate code or architecture. Instead, they channel their energy into designing tests that simulate real-world user interactions and verify if the system delivers the expected outputs for each scenario. With the test cases meticulously designed, the stage is set for test execution. This phase involves meticulously running each test case one by one. Imagine a tester as a conductor, leading the system through a series of user-simulated scenarios. As each test case unfolds, the tester observes the system's behavior with a keen eye. They meticulously compare the actual outputs generated by the system against the expected results that were predefined during test case design. Do these outputs align perfectly with what the user would expect based on the system's documented functionalities? By diligently comparing actual versus expected results, the tester can identify discrepancies between the intended behavior and the system's actual performance. These discrepancies, also known as defects or bugs, are documented and communicated to the development team for rectification. Now that we've unpacked the black box testing process, let's see how to put it into action. The first step to implementing black box testing is crafting a well-oiled testing machine, a comprehensive plan. This plan serves as the roadmap for the entire testing journey. It meticulously defines the test objectives, outlining the specific functionalities and behaviors the testing aims to evaluate. Additionally, the plan meticulously details each individual test case, acting as a script for simulating real-world user interactions. Finally, the plan incorporates the test data that will be used to feed the system during test execution. Now it's time to put the plan into action. We'll run each test case one by one. Imagine a conductor leading the system through user scenarios. As each test unfolds, we'll compare the system's actual behavior to the expected results. Any discrepancies, those are bugs, will be documented and sent to the development team for fixing. Through this rigorous testing, we ensure the system functions as intended by real users. Once the tests are complete, it's time to become detectives. We'll analyze the results, looking for any deviations from the expected behavior. These discrepancies or bugs will be documented in detail. But that's not all. We'll also prioritize the bugs based on their severity and potential impact on users. Finally, we'll use our findings to recommend improvements to the system, ensuring a smoother experience for everyone. If you follow this testing process to the T, there is a high probability that you would lower defects in the field. All the best in your test endeavor. If you want to know about any particular subtopic in this video, please comment below. See you in another video. Thank you for watching.